In some ways, that question is a circular statement. What's the probability that the p-value is less than 0.05 if the null hypothesis is true? Well, what is a p-value? It's the probability that you'd see data at least this extreme if the null hypothesis is true. Let me repeat that and see if I can get it to click that that's a circular statement. If the null hypothesis is true, the probability of seeing data like this, 0.05. What's the probability of getting a p-value less than 0.05? 0.05. Let me say it again. There is some particular cutoff. There's some particular type of data, some cutoff for our test statistic, such that we'd only expect to see data like that 5% of the time. And by definition, that's the cutoff for a p-value of 0.05. What's the probability that I see data like that if the null hypothesis is true? By definition, 0.05. What if I had chosen a different cutoff? What if I asked a different question? What if I said, what is the probability that when I do a simulation where the null hypothesis is true, the p-value will be less than 0.1? The answer is 0.1. Because there's some cutoff such that when the null hypothesis is true, I'd expect my data to be at least this extreme 10% of the time. That's the cutoff for the p-value of 0.1. What's the probability I see data like that? By definition, 0.1. What's the probability of seeing a p-value less than or equal to 0.1? By definition, 0.1. For any p-value cutoff I choose, the probability of seeing a p-value less than or equal to that value, by definition, is that value. The probability of seeing a p-value less than 0.05 when the null hypothesis is true, 0.05. The probability of seeing a p-value less than 0.1 when the null hypothesis is true, 0.1. The probability of seeing a p-value less than 0.37 when the null hypothesis is true, 37%. That's what we'd expect to see if we do a simulation, that 5% of the time the p-values are less than 0.05, 10% of the time the p-values are less than 0.1, 37% of the time the p-values are less than 0.37.